Welcome to the webinar on how to be successful macro front ends. We have a lot of ground to cover today, and we'll start with a short and sweet macro front end primer. For those of you who are just starting, and we saw some of you are researching or just starting with this topic. I promise not to be overly technical in the primer or any other section. So if you're more of a business person or new to this topic, you should be able to track with us today. Once we have those basics nailed down, I'll try to give a few reasons why a business should care about micro front ends. You can use this content and even the slide if you want to talk to your bosses, peers, or customers if you think micro front ends are good for the business. Then we'll move on to discuss a few common pitfalls and myths. That's going to be awesome. And followed by the architecture diagrams. I'll walk you through the basics of laying out the architecture, and we'll land the plane on a more complex use case that you can involve various use cases as white labeling, remote control apps, and so on. And then my buddy Josh, the product manager for Portals at Ionic, but he doesn't need an introduction, does he? Josh will introduce you to Portals for capacitors. We'll wrap it up with some of the key takeaways from this presentation. I'd like you to take notes and write down any questions. We'll block out some time at the end to address them. And I know what your first question is probably going to be, so you don't have to write it down. You're probably asking why you should be listening to me specifically. Primarily because I'm in your way if you're here to hear Josh do his magic, but also because, you know, I think I've grown lots of gray hair since this photo was taken, as I've been planning and architecting micro front ends over the past 6 or 7 years. And I really want you to keep your hair beautiful. I don't want you to make major mistakes. I want you to be successful. Some projects I obviously can't tell you a lot about, but I will actually back up a lot of this content with actual experience working with automotive giants like Audi, Lamborghini, Porsche, Mercedes. I'll talk about telcos like Verizon and AT&T, and e-tailers like Japan's Mammoth Uniqlo. So if any of this makes sense for you, you know, there are going to be a lot of interesting examples. While I can keep talking about me and the company I work for, Modus Create, for a while, I suppose we can get started with the important stuff. So let's get started with the actual primer, the intro to micro front ends. And I know a lot of you guys are watching this live or recorded later, and you're coming from different backgrounds and different towns. And you've probably been to large cities and small towns. And all these towns have their mayors. And I wonder if you ever, if you ever imagined what it would be like to run a city. So if you were the mayor of a small village town, you could walk around the town and probably know exactly what the state of it is. And you can stroll down the main road, by a construction site. You can even stop by to chat with the contractors to see how things are going. You can pass some tools. It's very cozy that way. You have everything under control really easily. But if you're the mayor of New York City, well, now you need an airplane to see what's going on, and you still want to see everything. It's like running a country, really. So mayors of large cities, they divide and conquer. You'll probably have people or teams actually to help govern areas like Brooklyn or Manhattan. And in fact, you might even have people focusing on much narrower context, like maybe the financial district specifically. And these people you would expect would be experts at their field. So these specialized experts might as well be running micro front ends that integrate into a much larger ecosystem or city or a highly scalable application. So micro front ends are just that, an organizational pattern that promotes decentralization by decoupling a monolith into independent features. Dedicated teams will own the decoupled features, and they become experts in that business domain. So for example, Amazon could be that large scalable application. And there could be a team that's responsible for managing the cart experience only. Notice that I'm not saying that micro frontends can do something monoliths can't. This is not a battle between technologies. This is just using technology to implement organizational change. So some of you may already be involved with a large-scale app that's designed as a monolith. And that means that the whole app is in a single code base, and perhaps it involves a complicated build step to release the entire code base at once. Migrating a front-end to micro frontends is very similar to migrating a monolithic backend into microservices. So if it makes it easier for you, you can think of micro frontends as microservices for the user interface. In fact, to take advantage of the specialization of the expertise that we talked about from the New York City example, we might even combine the ownership of full stack capabilities to the same team. For example, that Amazon's cart team could own both the UI and the backend logic that's related to that cart functionality. And that makes a lot of sense, doesn't it? So I just help you see cart as an independent feature. That's great as a micro frontend, but what else in your app can be a micro frontend and what not? So basically, where do we draw the line when we decouple an application? If you're not familiar with atomic design, which is what this figure on screen represents, know that atoms are UI elements like buttons, and molecules could be slight combination of atoms like maybe tabs, which has buttons and a view layer. Molecules and atoms are too small of fragments for micro frontends. So it's best to keep them in the component library, like Ionic or your custom design system. Now, organisms, those are already a more meaningful set of components. This is where we start slicing. As an example, the comments feature on YouTube, or the reviews on Amazon's product detail page, or even the car configurator on Audi's website. Those are all great examples of micro frontend features. This slicing is also known as horizontal slicing because multiple micro frontends can exist and coexist on the same page. On the other side, we have vertical slicing where we decide to decouple entire pages or views. Now, horizontal and vertical slicing have their own benefits and their own problems, which could be probably a webinar on its own. So we're not going to take a deep dive into that. The remainder of the presentation will be very agnostic of which slicing pattern we choose, but we will kind of slightly lean towards the component or horizontal-based slicing. I think it's going to be easier to track. And if there is one thing I want you to take away from this slide, is to not go too granular with slicing micro frontends. I've seen companies not have a good time with that. Think about business focus, and that was very important from that one of the previous slides. Teams are focused around a business unit, so non-UI components. In this example, with Spotify, we can see examples of what micro frontends could be. Right? I'm not saying that this is how Spotify is sliced, but this is what it could be sliced like. The audio player at the bottom is a great example. A team in charge of maintaining the audio player are most likely the experts at audio reproduction. They know how to stream, they understand media compatibility of each browser and mobile platforms, they understand audio security, and so on. And on the other hand, we have this red box, which is the song card. That's not a good micro front end. That's more of a component that you can reuse in multiple different micro front ends. So the audio team are experts, and they will want to be the bosses of their little world. With that in mind, a micro front end team that owns a feature like the audio player is in charge of the entire lifecycle. They're in charge of the business logic, tests, build step, CI/CD, tracking and analytics, dependency management, and so on. They have their own little kingdom to rule, right? But if you remember that analogy with New York City, that borough is not completely independent. They still need to adhere to certain global rules and laws. Their front end will eventually be integrated into a whole, into Spotify, into New York City. We have to know how we how we integrate. So micro-front organizations often define a solution architecture team or teams as a response to the question of who owns integration. Someone usually needs to work out how features are connected together, how end-to-end tests are executed, the design patterns, communication patterns, and such. Solution architects are skilled and experienced engineers. They take the most complex architectural issues so that our teams can really focus on what they do best. So usually we put the most skilled people in that one team so everybody else can just enjoy building what they know best, what they are experts at. So why would businesses really care about this? I really love this photo because it illustrates what specialization means for successful teams. And I think you get that too. Let's talk about this pit stop timing for a second. Even if these engineers can replace the tires and refuel in just 3 seconds, the driver will lose about 20 precious seconds due to slowing down through the pit lane. They almost always lose their position, at least temporarily. Now imagine if replacing a tire could be done with software. Now then, your Formula One car would always be incredibly fast and incredibly safe because you would always have the latest tires and the optimum amount of fuel. And I think this is what micro front ends can provide to a business. If we no longer require the entire monolith to rebuild and to ship, it becomes much easier to replace a small part of the solution, a feature, with an updated version. And you can do that on the fly. Micro front ends are actually built to support all that natively. Now, the software for that exists to support that on-the-fly updates, and you don't really need to develop that internally. Ionic portals are perfect for that task, but we'll get to hear Josh tell us more about portals in a little bit. So micro front ends can be homogeneous or granular, as works best for your teams and business and your users. And because digital presence is so nicely organized, it becomes almost natural to update parts of that app on the fly, to roll out new features to test groups, and even to automatically roll back to the previous version when regression is caught in production. Imagine that. Keep your application healthy automatically. So if you've ever migrated an app, you know how migrations are painstakingly slow and expensive for monoliths. But they are not as complicated with micro front ends. Micro front ends are built for faster and more agile migrations and updates and hotfixes, because we are focusing on features which make up a much tighter scope than the monolith. It's like building an app with with the triangular pattern facade built right inside. And in the agile spirit, microfrontends make it easy, almost native, to learn, adapt, and iterate through products. Microfrontends are much more an organizational pattern, as I said, than a technical solution. And that organizational pattern is very, very agile. If you're a part of a complex agile methodology like SAFe, microfrontends work really, really well with that kind of methodology. They're perfectly compatible and friendly with SAFe and Scrum, the Scrum of Scrums and all of that. In that same, on the same note, microfrontend, because they're so agile, they democratize development by enforcing ownership of a business subdomain. You just get experts all over the place, and teams get to decide how to plan, how to develop, release, validate. They decide how to fix. It's no longer required to plan for maintenance of the entire system, when features can update independently without breaking integration. And we get to another business benefit, which is one of my favorite opportunities, and that's being able to read cost benefit, not per app, but per feature. So with the right architecture in place, microfrontends can make that analysis a lot more granular. You can easily measure the cost of a feature in cloud infrastructure, and you can use those metrics to improve the bottom line. You could probably connect that when we get to the slide when we talk about complex architecture. You'll see how that really makes sense. But in case you are under the impression that microfrontends are a new catchphrase, you're probably right. And however, they are not a new invention. Microfrontends have been around for decades and have recently gotten a lot more powerful with the advent of new technologies like module federation, for example. At Modus Create, we've helped most of these organizations, most of these brand logos to double down on microfrontends very successfully. And it really works well for large systems. Now, let's talk about a few scenarios that people often ask about. And I know that you probably saw that the internet is full of opinions, and I want you to be able to make the right decision without being subjected to misleading information. I was recently invited to a podcast where we talked about microfrontends, and to my surprise, most of the time was spent in the interviewer challenging me about how much freedom is the right amount. But autocracy doesn't really work very well anywhere. So why should it be included as part of a decision-making in microfrontends? And lots of people actually believe that microfrontend teams should be able to choose the entire stack, including the framework. Yeah, I can see how that makes sense. It's appealing. Why wouldn't I use React because that's what I know best, and you can use Angular because you feel comfortable in it? And that would be fine if we were serving pre-generated static content, which is not very often the case. It could also work if you slice apps by pages or entire views, that vertical slicing. But that decision, if you go that way, that decision will create lots of problems in managing shared dependencies. It's also going to make problems, it's going to be very difficult to move people from one team to another if the core technology is that significantly different, right? So we want to have a little bit of overlap. Now remember, and always remember that, I find that often really hard to keep on top of people's minds, is that microfrontends are always going to be a part of a whole, part of a system. If you think about it, you would probably never build a classic monolith application with multiple frameworks, now would you? It's much easier to double down on one core architecture, just the minimum core, and then work with that. So the next thing is, well, if I really made you think that microfrontends are easy, and I did speak to a lot of benefits of microfrontends, but if I made it sound like microfrontends are easy, then I really failed. And just like that New York City mayor would implement a much simpler governance structure to a small village town, we don't need to worry about microfrontends for small apps. I would say that if your app is maintained by, say, 3 or more teams, and you have more than about 1 million users, I'm making these numbers up to show you the scale. And then you can start considering microfrontends. They're really made for highly scalable systems. I mentioned SAFe and Scrum of Scrums, and that's made for highly scalable systems with many teams as well. So that's where it works best. Organizations that feel they will make a few smart architects busy and the migration to microfrontend is done, well, those are just wrong. Remember how I said that microfrontends are made for agile teams? That means that they require an agile organization structured to support such an infrastructure. And conventional, or should I say conservative, organizations struggle with their org chart more than the architecture diagram. So I won't give you a definition of an agile organization versus a conventional organization, but I hope you get the point. The thing microfrontends are great for. They are great for large organizations, and large organizations can often be less than agile. Usually, at least in my experience, we work with smaller teams. They tend to be a little bit more agile. It's normal. But this is not a dead end street. So if you're part of a large organization, that doesn't mean you shouldn't go. This is definitely a good fit. But experienced consultants can be a great help with that organizational change. Just know that the change doesn't come overnight. Give it time. Plan for maybe 6 months to start getting some traction, right? I'm always in favor of that build one to trash one. I found it very useful for organizations to be that flexible, to start creating a prototype so that they can learn how it works, and then they can adapt before they start building the real thing. Then monorepos. Monorepos do sound like a great way to keep all microfrontends in the same place. But I would advise against that, because monorepos are, they're just like an apartment building. You have a small piece of real estate, but you need to follow those common rules like no pets, no loud music. And how can you build a music app if you can't play loud music, right? So there are too many shared agreements and workflows in monorepos for a healthy exercise of ownership and self-organization. So technically they can work, but I would urge to rethink that. And speaking of monorepos, let's spend some time discussing architecture diagrams. We're going to see them again. As I mentioned, microfrontends have been around for decades. And some of the first apps use frames and server-side includes. IKEA is a known brand to have used, and I think they still use server-side includes to integrate microfrontends. Basically, they patch them together in a patch. A modern version of server-side includes are edge-side includes, where things happen in the cloud. Then we have submodules in monorepos, also a way to bring code together, right, through source code management. And some people, I know that some people use NPM modules in a private registry to bring things together. And that sounds very, very logical, right? But I think the best thing I can compare that to is module federation. Module federation is awesome in many ways, and it's different than all of these. You can find module federation in lots of build tools, particularly Webpack. The major benefit of module federation is that integration at runtime. That's really powerful. And this allows replacement of micro frontends without any technical intervention because it's happening on the front end, no build steps. It's very, very powerful. Module federation ships with a wonderful runtime that can be configured to automatically share dependencies between micro frontends. And that runtime can figure out the best place to load them from semantically. You know, we can talk a lot about module federation. I find it really a fantastic technology, but I just wanted to introduce you to it so you see the difference between the other technologies. And as we talked about diagrams, so I have module federation in mind in the diagrams because the benefits of module federation surpass everything else. So this is an example architecture. This is a small app core that is deployed, right, and loaded in a browser. So the app core is in the cloud, it gets loaded in the browser, and based on the configuration, basically the manifest, it pulls micro frontends from the cloud. The process is ridiculously fast. If you think about it, you'll notice that this is built to minimize bandwidth as clients progressively load only the code needed to display the UI on the screen. Micro frontends like this can be used on any device. And I have a crazy example for you. A few years back, I participated in a prototype where we deployed the core of an app to a QNX embedded car and infotainment system for Mercedes. Then we established a solution that downloads federated modules. Now this wasn't a module federation, it was in-house system. Module federation is far better anyway. So we would download federated modules that can either be software upgrades, regular upgrades or updates, or they could be subscription-based services. Now think about upgrading the animation of your turn blinkers for $1 a month, right? And then you get that from the internet update uploaded or downloaded to your car. And that architecture is very similar to this. And this can be done with micro frontends. If it can work in an embedded system, micro frontends can be used in mobile apps as well. Now the twist is you'll need a small native shell, which is basically your capacitor installation. When we started the migration of major telecom, their personal cloud monolith, we decided to keep all the native functionalities as APIs, not as views. So just the native APIs in that native shell. And think of those as capacitor plugins, right? That made code reuse between the PWA and the mobile incredibly high, as the application can easily detect the presence of native APIs and then dynamically load additional micro frontends as necessary, right? If we detect we are a native, we can automatically instantiate micro frontends that can leverage those native functionalities, or if not micro frontends, adjust the features. But to play along, there's a catch. To play along with the rules set by the app stores, you'll have to ship all the possible micro frontends into the initial bundle. You can't just download them from the web. They're not going to like that. So you have to bundle everything together. But you can update hotfixes and minor improvements over the air. Again, to do that, I would definitely opt for using portals because you'll see portals are amazing at this kind of dynamic functionality and updating and managing features. So now that we talked about these, say, simple examples, this is something that I find far more exciting and powerful. This is actually a simplified version of an existing system we put together. We call this kind of architecture feature as a service. I think you're going to get why as I explain it. The ecosystem is improved by adding the feature app. So micro frontends, we start calling feature apps. Feature app registry in the middle. Now this registry is really cool. It knows what all of the available features are, or micro frontends feature apps are, knows their versions, compatibility tables, documentation, where they're implemented, and so on. The app core then asks the registry, hey, give me the best version of this feature. And then the registry decides, what to feed it with, right? The registry can automatically invalidate a faulty increment and serve the last known good version. Incredibly powerful that feature app registry is. The good thing is, as I mentioned, a lot of this is that part where I can see portals being a very important piece of that. So the manifest used to decide what features are used on the screen is then defined by content authors. So it's no longer a part of apps configuration. It becomes live because content authors operate on that manifest through a headless CMS. That becomes the control panel that non-technical users can use to configure the app from a remote location. Now imagine drag and drop little pictures of features. They configure it in a very human-friendly format, and they press that red button, and users get to see that, obviously following quality assurance. That's incredibly powerful. Then we also have that white label management that you can see in top left corner. The white label manager component, where you can easily instantiate new app cores for every new tenant, and basically turn the registry into your internal app store, your own app store. So you can sell features to the white label customers. Now imagine you have a bank of features, and you let your white label customers choose which ones they want to purchase from the organization. And then you track that cost benefit. You know how much those features cost, you know how much you're getting for them, and you can tune that. Incredibly powerful. But this is all made possible with a very simple pattern. Very simple to understand, at least, but it is complex to implement, and that's micro frontends. Luckily, some of that complexity, as you can see, can be, I want to say, offloaded to portals. And trust me when I say that, because I have felt the pain of working without portals. So Josh is the product manager for portals, and I will let him take the lead from here. Josh?
Thanks, Grgur. Portals for Capacitor is an Ionic product for transforming capacitor-based mobile apps from monoliths into micro frontends. So typically large applications have multiple teams contributing, and the teams are separated by feature, as what Grgur said earlier. They're delivering updates through a single pipeline, trying to find a way to coordinate within the monolithic code base. This can lead to bottlenecks, delays, missed deadlines, and overall customer dissatisfaction. With portals for Capacitor, multiple teams can deploy their micro frontends in parallel without needing to coordinate all feature development into a single code base. This leads to faster development time and improved scale, multi-platform feature development, and overall the ability to build and ship in parallel by removing the deployment dependency between teams. So to make this work, the development team knows that they need to move away from a siloed application and move more to a vertical of feature teams. So this configuration also ensures that backend and front-end developers are all working toward the same goal. For the backend teams, they've adopted a mindset already of microservices, but front-end teams are slowly moving to this concept of micro front-ends. And the best part of this structure for an organization is as the organization scales and more feature teams need to be added, can be done so with the confidence that they're not going to delay the development or deployment of existing feature teams. So Portals for Capacitor offers this plug-and-play solution for organizations with numerous Capacitor web teams. With Portals, individual web teams can build, deploy, and manage their contributions and features autonomously. So this is our product for existing Capacitor applications that can leverage tech that the web has to offer to be able to deploy autonomously and with confidence. But if your team is not building Capacitor applications, Portals for Native allows you to input a web application into an existing native application. So this provides a way for your native applications to take advantage of micro front ends and offer feature teams independence as well. This is likely a tech and an approach that you probably haven't seen before, but bringing micro front ends to native mobile applications can offer some substantial benefits when compared to traditional native development. So I'll give it back to Grgur now.
Thank you, Josh. Let's talk about takeaways. Now, I really want you to take just these 3 takeaways, if there's anything that you remembered from this slideshow. And then again, you're going to be able to see this recorded. You're going to be able to come back. But if there are 3 things you can take home, is micro frontends are a great fit for large and scalable apps, but may be an overkill for small products. It's also more about the organization being ready to adopt the new pattern than it's a technological marvel. However, don't think that the architecture is not complex. It definitely is. Because I've seen the price companies have paid with the setback caused by the lack of maturity, I really advise getting external help, at least to get started. I think it pays good dividends. All right, it's your time. Let's see if there are any questions.
I think there's one question that we've seen, which is, it's not about can I, but should I? And I think that this is really like speaking to what are the possible caveats of when should you not think about implementing micro front ends? Grgur, you probably have a pretty strong opinion on this.
Well, I would say that, so when you look at micro front ends, there is the cost of decoupling. There is a cost of synchronization. And if the way I think about that, wherever there are bridges to be crossed, those bridges become bottlenecks. It's hard to pinpoint the exact number. And I would always recommend creating a prototype, something small. Scope it to 2 or 3 weeks, see how it works. But it has to be incredibly small so you can experience the entire life cycle. I'll be honest, there is this incredibly big micro front system that I'm currently involved with. Includes 190 markets globally. Thousands of people are into teams. I think just not thousands, but just over 1,000 people make all the teams that create that micro frontends, right? Those are engineering teams. And it's been maybe 2.5 years since we switched technology but the organization has been working on microfrontends for at least maybe 5 or 6 years. And we are still experiencing new things that we haven't experienced before, new problems, new challenges. So that said, there are obvious, I'm going to say, as I think mentioned before, if it's a small product, you don't have to worry about that, because switching to microfrontends, given that the product hasn't grown significantly, switching to microfrontends is usually not very painful. You can really do that very fast, again, given that it's not a big thing. So be agile, right? Work. It's an agile approach to even migrate. It would be probably helpful to know more about the actual use case. But again, as I mentioned before, if you have lots of users, if you have lots of turnover in the way of it's a big app, it has to update frequently, then those are cues, right? Those are cues where you can start thinking, maybe I can start creating expert teams. And again, it depends on the business, because teams are experts around certain business scope. And if you feel that this is what your organization can benefit from, having experts in certain fields, then absolutely, I would say try. If that didn't help, let me know. I can come back to that. There is another question. What about sharing security across multiple front ends? How to handle it best? I'm not exactly sure what sharing security means, but there are definitely lots of security questions that I've seen arise. So obviously there is a security of deployment and how things get pulled from the internet, right? If you have things on CDN, here's a catch. I really like this one. So if you deploy everything on CDN and you decide to keep different subdomains for each feature, which is awesome because it really helps you get more of that cost tracking. Well, it gives you a lot of other things, but if you do decide to do that, then you should always use course security. If you don't, this is a little bit technical, but if you don't specify course specifically, even if it's the asterisk, I'm allowing everything. If you don't do that, you get opaque responses, which really don't work well with caching. They report the wrong headers. They report the wrong size to the browser. You can, maybe an app of 200 kilobytes can be shown as 400 megabytes, and you exhaust your storage quota on your device, and it can even crash. But not because you actually use a lot of data, but because the opaque response, because of the security, opaque responses are like that in browsers. Security in terms of communication with the backend, it's just the usual. It's just very usual, right? The security around what can I download? Again, it's very common to any static content. You can secure any static content through, if it's on the cloud, the serverless functions, right? Like Lambda. You can use security in Lambda and protect content. So I would say all the standard rules apply. Microfrontends are, as I said, are not a technology. They're mostly an organizational decision, and how you couple that back together into a whole. It's standard base, right? So you apply any standards. Did you want to add anything else, Josh?
No, I would agree with you. I think when you look at something like module, like the specific implementations, right? Something like module federation, like essentially you're all running in the same runtime, right? So you're, taking on the standard practices you would for most web development and how you protect and share that information across your application. So I would say the concerns you would have with a typical web application would be the same concerns you would have in this case. And I think that's something that you spoke to. There was a question here that I want to answer, which is, can you use module federation with capacitor without using portals? If so, why use portals? And there was also a question about using this with Cordova. So portals for capacitor was built specifically for capacitor, and it will not work in Cordova applications. So module federation is a way of separating your application into features, right? So if you were not using portals for capacitor, you could still use module federation, but you're not getting the benefits of it. Module federation and splitting into micro front ends, the value is really in the autonomy and the ability to do deployments independently. So if you were to do module federation in an existing capacitor application, your deployments are still going to be releasing to the App Store or using an over-the-air update system like live updates. What portals for capacitor brings is the ability to create separation in your application so that you can have multiple apps that can be independently updated through an over-the-air system. So if you have a single capacitor application, you still have a single pipeline, but if you use portals for capacitor in that application, you then can increase the number of pipelines and teams that can contribute independently and release independently. So hopefully that answers it. Let's see, did we have any other questions?
Josh, I'm looking at the questions and I'm seeing a few regarding, let me try. So there's one, if we have a good example of the template of the application core, I would say this is fantastic. The application core can be a micro front end too. It's just a regular micro front end. Everything that you see here, because micro front ends can nest other micro front ends. And so why not make one as the king, the core, the mothership, the motherboard, right? The one where you plug everything in. It can be anything, but with any application core, make it extremely light. Only the absolutely important things should be in it. Don't make it big. There are other questions like, there are a few questions around dependencies. There is a question about mixing front-end technologies. There is a question about, shared duplications of shared, I'm not sure if this is micro front-ends or again, dependencies. There are lots of concerns about this, right? There's always going to be two kinds of, I want to say dependencies, two most important kinds. One is in module federation world, it's called a singleton. In your application, that could be React and React DOM. You can only have one version of React and React DOM. You can only have one version of styled components, but you can have multiple versions of Lodash. Because the thing is, React and styled components, right? They need to have this unique shared memory allocation. They need to think about the state of the app from the central point. When you have multiple versions laying in the app together, then they need to be agnostic of what's going on. And that's one thing about micro front-end. When you build an app, micro front-end, one federated modules, but you really build it in isolation. It's an app on its own. That's why I love to call it a feature app. You think of it as an app, but you also have to think about integration. So with module federation, you can automate this. You can easily automate all the dependencies from package.json to be your shared modules, and the runtime is going to figure it out automatically. It's going to load the best version. But if you use semantic versioning, major versions are not going to be. So major versions mean breaking changes, and you can configure that, right? And whenever there's a major change, then you can say, oh, I'm going to load two versions, right? Two versions of Lodash, version 3 and version 4, for example. And they can coexist. It's totally okay. Shared modules do remove some of the capabilities for tree shaking, unfortunately. It's just the way it is. You never know which other module is going to use some of the features in it, so they ship as they are. But you can easily leave it to be independent. The the fewer of these singletons you have, the better. If you love style components, I appreciate that. I will share that I've seen them create lots of issues because of them being singletons. Now imagine you have the app core, you have 100 features, 100 federated modules, and then you have the maybe the CMS and data source, and then to update something that creates a breaking change that needs to be updated simultaneously and synchronously in all locations at the same time. That is problematic. But if it's not a single, if it's something that's agnostic of memory, or if you're gonna work to create your own shared memory module, we've done that too. It works. If you can do that, then you never have to worry about synchronizing updates. We even have a deployment live, and you might laugh, but there the core ships with React 18. Feature apps are developed with React 17. It's totally okay because they are really good at working on backwards compatibility. Hope I was able to be helpful with that answer.
It's one of my favorite things about React is how consistent the API is across major versions.
So again, we have a mix of front-end technologies as a question. I would say, do yourself a favor, don't mix frameworks. Don't have Angular and Vue and React. If you're using a rendering engine like that, just use one. Eventually, you're gonna probably have a common library of useful tools like authentication or localization, things that lots of feature apps use or micro frontends use that are not really micro frontends, but they are utilities, as I said, like, you know, localization, language switching. Having them in a reusable library that is on the level of any dependency, that's useful. And if you have multiple core frameworks, that makes it a bit more difficult. So whenever you can, try to stick to the standards. Like in the previous example, when I forgot to say that, when you said, when I said style components, when I saw the problems this organization was having with updating style components, especially now with the React 18, you have to update to a new version that has different API signature. So it's a breaking change eventually. So I always ask, why didn't you just stick with the standard? CSS, you know, it's a standard and you don't have to worry about singletons. I don't want to start a CSS versus JavaScript, CSS and JavaScript war. I'm just saying standards are good. If you guys are here, if you're following Ionic, one of the best things I love about Ionic, and I'm not affiliated with Ionic, one of the things I love about what you guys do is that you are so standards based, and that really makes our lives easier.
I think that one of the problems, the biggest problem I have personally with mixing front-end technologies is not just like the problem with managing the dependencies and the bloat and the problems with an organization, but it's also the user experience, especially from web. The amount of JavaScript that you have to download and the file sizes and the eventual impact on the user experience is just something that I don't think there's enough value for an organization to have that kind of impact on their users. So I would say as much as possible, try to keep it to a single front-end tech, but yeah.
There is a question about upgrading or updating a container for hybrid apps. I think this could be a good question for you, Josh.
Yep. And I think that the way we talk about portals for capacitor is taking that singular container and breaking it into smaller containers, right? It's on device, on physical device. It is still just a single package that is installed. But what it does is it gives you multiple deployment targets for live updates. And that's really the value that Portals for Capacitor brings, is that by having multiple deployment targets, you now have the ability for teams to deploy independently of each other. And using a tool like Module Federation to connect the dots between them just makes it a much easier experience moving forward for MFE development within mobile applications.
We are about at time. I would love to really thank you for all these amazing questions. This doesn't mean that you shouldn't ask questions in the future. Josh and I are going to be available if you have any questions. Post this webinar, feel free to contact us. And Josh is always very helpful to me. I know he's going to be helpful to you, and I would love to see those questions.
Awesome. I just want to say thank you so much to Grgur and our friends at Modus Create for presenting alongside us today. If you do want to, reach out to us, if we reference, how many of you were in that research part of your journey with micro front ends, about 66% of you said that you are in that research stage, please feel free to reach out. Modus Create has their web link there on the slide, and then I'll be including a link in the chat for everybody to reference to learn more about Portals and reach out to us, because we're happy to answer more of your questions or to continue the conversation. But for now, just want to reiterate that this presentation has been recorded and a recording will be made available to you shortly. But thank you so much for joining, everyone. We look forward to seeing you at our next event. Thank you.
Thank you so much.